Do you want to become a Solidity master? Well, I'm going to give you an introduction to the Solidity programming language so you can do exactly that. I'm going to cover all the essential aspects of the Solidity programming language so that you can code your own smart contracts and become a real-world blockchain developer. We're going to start off with the basics, like, hey, what are variables? What are the different data structures and types? And then quickly move to more advanced concepts and put it all together by creating our own smart contracts. And you don't need to be an advanced developer to get started on this right now. And so, for the astute observer, if you have watched my channel before, I've done a video kind of like this in the past, but in this video, I'm launching a new and improved version of the Solidity programming language for beginners with the latest Solidity programming language, version 0.8. And so if you're new around here, hey, I'm Gregory, and on this channel, I turn you into a blockchain master. And I've helped thousands and thousands of people become real-world blockchain developers. So if that's something that you're interested in, then smash that like button down below for the YouTube algorithm and subscribe to this channel. And if you want to know how to master blockchain step-by-step from start to finish, then head on over to dappuniversity.com/bootcamp to get started today. All right, so let's jump into this. A quick overview. What is Solidity? It's the main programming language for writing Ethereum smart contracts for the Ethereum blockchain and other EVM-compatible chains. It's an object-oriented language. It's high level, and it's honestly pretty beginner-friendly on the grand scheme of things because it's heavily influenced by Python and JavaScript, which are also other pretty beginner-friendly languages. It is statically typed. Okay, it supports inheritance, libraries. It's a fully fledged programming language, as we're going to see throughout this tutorial. And one of the main things I want to focus on in this video is the features of Solidity version 0.8. So this is the latest major version of Solidity. And this technology is changing all this time, and I want to create this video so that you all can understand how this works with the current version of Solidity. So now let's start coding. We're going to do everything inside of our browser without having to set anything up on our computer. We're going to use Remix. So head on over to remix.ethereum.org. So this is a browser-based IDE where you can write Ethereum smart contract source code. You can see examples here in the contracts folder. Okay, we're going to create a new smart contract in a second. You can also compile the smart contracts in this tab and then deploy them live to a blockchain all in your browser. Okay, so we are going to work off a set of examples here. You can see this tutorial repository here on GitHub. I'll put a link to this down in the description below. It's got the examples that we're going to work through. So if you want to find the solutions after the videos, you can do that. But let's go through these step by step and learn Solidity. So the first thing we want to do is create a new file here at Remix. So on the sidebar, click this paper icon right here, and let's create a new file called counter. So capital C, counter.sol. So we use capital letters for smart contract file names, and we use the .sol file extension for the Solidity programming language. So the first thing that we want to do is declare the Solidity programming language version at the top of the file like this. We say pragma Solidity, and we're going to use a caret here. Okay, and then say 0.8.0. So that will mean that we're using at least version 0.8.0. We have to tell it what version of the programming language we want to use so that the compiler understands that from our smart contract. So the next thing that we do is we create the smart contract like this. We use the contract keyword, contract, and then we give it a name. So I'll go ahead and bump this up so you all can see it, okay? So contract, counter. So capital C, counter, just like the file name. And then we use these curly braces like this. And then all of the code for the smart contract goes inside of here. All right. So on the Remix page, or excuse me, the Solidity page, it talks about how Solidity is an object-oriented language. So that basically means that the contracts themselves are sort of like objects in other programming languages where they support inheritance. You can call other smart contracts, and also that contracts are the basic unit that you can reuse inside of the Solidity programming language. So this contract is an example of that. So all of the code that goes inside of here is kind of like going inside of a class with another programming language. All right, so let's create our first code here. What we're going to do is create a basic variable inside Solidity. So this counter contract, what does it do? Well, it's basically just going to store a count on the blockchain, and we're going to let a user change that count by 1. So example, we're going to have this variable called count here. And, this variable value could be 1, 2, 3, et cetera, and we're going to let the user set this value and make it go up and down. All right, so we can declare a variable inside Solidity like this, specifically a state variable. So what does that mean? Well, a state variable is a variable that's actually stored on the blockchain itself. And we create state variables inside Solidity by just declaring them inside the contract, not inside of any functions or anything like that, just inside these curly braces. Okay. So we create this variable named count, but with Solidity, we have to tell it the type of variable. Okay, so basically, Solidity is a statically typed language, which means whenever you are declaring a variable, you have to tell the type. In this case, we're going to say it's an unsigned integer, so uint. Okay, so what does that mean? Well, an unsigned integer is just an integer without a sign. So, the count can be 1, 2, 3, etc., etc. It can be an integer, but it can't have a minus sign in front of it. So it can't be -1. This is a sign, so it can't have a sign. So unsigned means that it's an integer that's only positive. All right. So again, statically typed uints means that this variable value count can only ever be a uint. It can't be a string. It can't be an array or anything like that. So now let's create our first function inside of Solidity. So what is a function? Well, a function is just a piece of code that can be reused and called over and over again inside of smart contracts with a certain set of steps. Okay, so you say step 1, step 2, step 3, and then you can repeat those steps whenever you want to simply by calling the function. So in this case, we're going to create a function that just gets the count that's listed here. So we'll do that like this. We'll say function get count. Okay, and then we use these parentheses like this, and then we give it some curly braces. So that's all you need to do to create your first function. You create the function keyword, you give it an arbitrary name that you decide, and then you use these curly braces if it has arguments or not, and then the function code goes inside of here. So what we're going to do inside of here is just return the count. Okay. So the return keyword is what we use inside Solidity just to specify, what this function is going to give back to the person that's calling it. In this case, it's going to be this count that we're reading directly from the blockchain. So the next thing that we want to do is declare the visibility of this function. What does that mean? Well, we're going to add this modifier like this. We say public. Okay, so what does that mean? Well, it means that now we can call this function outside the smart contract, because in a minute, we're going to put this contract on the blockchain and we're going to click some buttons that talk to the contract to actually read this count. And we wouldn't be able to do that if we didn't have this public modifier here. So Solidity supports other modifiers like internal and others, which we'll talk about later, so to where this can only be called inside the smart contract itself. But for now, we're going to make it public. And then next, we're going to say it's a view function, and that it specifies that it returns this value, returns uint. So this tells it the data type that the function returns. In this case, it's going to be a uint. Now let's create a new function to set the count. So we have get count. So we'll create a new function just like this. Function increment count. And then we'll use the curly braces, or excuse me, the parentheses. And then we'll say public. And then we'll use curly braces. And so this is going to be our function that we call to change this number and make it go up. So how do we do that? Well, we can get the count from the blockchain like this and say count equals count plus 1. And then we want to follow that with a semicolon. So I meant to mention that earlier. We definitely want to add semicolons after each line in Solidity, except when you're creating functions like this. So we have a semicolon here, and a semicolon here. So how does this work? Well, essentially what we do is we get the value of count from the blockchain like this. We say count, okay? And then we just add 1 to it. So we say count plus 1. You can do math pretty easily in Solidity just like this. And then we use the equal sign, which assigns the value back to the original variable. So we just read count, we add 1, and we save it back to count here. And again, whenever we save this, we're updating this value to the blockchain itself. That's what a state variable is for. It's stored on the blockchain's state. The state of the smart contract is decided by the blockchain. And whenever these variable change, we change the blockchain. And whenever we do this, we have to pay gas. So this function is a write function. And therefore, we're going to call it public so that we can write it on the blockchain outside the smart contract. Whenever we write it, we have to pay gas. So there's 2 types of functions in Solidity. There's read functions, like getting the count here. We just get this information from the blockchain. And then write functions where we actually change the blockchain. So reads are free on blockchain and writes cost gas. So we have to pay a gas fee, which we'll see in a minute whenever we do that. All right, so the next thing that I want to do is set the default value of count. So we have created a way to get the count from the blockchain and increment the count. But right now, we don't have a default value set. So I'm going to do that with the blockchain's constructor function, or excuse me, the smart contracts constructor function. We'll do that like this. We'll create a special function like this called constructor. Okay, and we'll call it public. And then we'll write the code inside of here. We'll say count equals 0. So what is this? Well, a constructor is a special function for each smart contract that gets run once and only once. Whenever the contract is deployed to the blockchain, or whenever it's put on the blockchain, or whenever the contract's created, those are all the same way of saying the same thing, or different ways of saying the same thing. So whenever we create the special constructor function, we just use a constructor keyword. If we have any arguments, we can put them inside of here. We don't currently for this one. And we want to make our constructor function public so that it can be called whenever the contract is initialized. So any code that we write inside of here will be called during the contract creation. And the only thing that we want to do is just set count equal to 0 as a default value. And we can set this to anything we want to. It could be 1, it could be 2, it could be 3. But for now, we'll just do 0. All right, so let's test this out. So we have created some Solidity source code here, okay? But now what we want to do is put the contract in the blockchain, which is a 2-step process. The first step is going to be compilation. So you can go to this right here, Solidity compiler. So what does this do? Well, essentially, this just takes our human readable code that we've created here and turns it into machine readable code that can be run on the Ethereum virtual machine or the EVM, okay? Whether it's on the Ethereum blockchain or another EVM compatible chain. So we can just click compile, all right? And you can see it's got some warnings here. Let's just fix this. Let's go into our file here and let's add this license identifier, okay? This is a special thing that most compilers want to see now. So we just say SPDX license identifier, MIT. All right, let's compile it again. All right, we're going to ignore this for now because we're going to remove the constructor function in a minute. It's just a warning. We'll be able to change it. It's just talking about the visibility. We'll update this momentarily. But let's click compile. All right. And then you can see that this is successful. And what it does is it turns it into bytecode. So you can copy this bytecode. You can click it here. And I can open my text editor. And here you can see the actual bytecode that is generated, and this is the machine readable code that's going to get run on the EVM. Okay, so we don't have to understand this, but I just want to show you what compiled smart contract code looks like as opposed to the human readable code. So now let's deploy it. Okay, we can go to this tab here, and now we can deploy it to a JavaScript blockchain in our browser. So this is just a fake blockchain right here. You could do different environments, but we'll just do the fake blockchain in our browser built in JavaScript. And you can see it's got, several accounts here, each with some cryptocurrency credited to it, which makes it nice and easy. We don't even have to install a wallet. We don't have to run a blockchain on a computer. No, nothing. You just go to Remix and start writing your smart contracts. So we can deploy it like this. We just click this deploy button and boom, there you go. So I'll pull this with my screen in case it's cut off at the bottom. You can see the actual transaction that was triggered right here. So this shows you all the details of what happened when we put the smart contract in the blockchain. So again, whenever we're putting contracts in the blockchain, we're creating a transaction. What is a blockchain? It's a worldwide computer basically made up of transactions. So, all the data on the blockchain is contained in transactions, which are grouped together in bundles of records called blocks, which are chained together to make up the public ledger. And anytime you do anything in the blockchain, whether it's send cryptocurrency from one account to another, whether you call a smart contract function, where you put a smart contract in the blockchain, you're creating one of those transactions. Okay, and that's exactly what we just did whenever we put this smart contract to the network. And when we did that, we had to pay a gas fee. So you can see that some cryptocurrency was taken out of this first account right here. So this was 100 Ether, and now it's 99.99 Ether. Okay, and we can see our final smart contract deployed right here. And we can even copy the address if you want to see that and then paste it right here. Okay. So now we can get the count. All right. By clicking this blue button here, this calls our get count function. We see it's currently 0. And then we can call increment count. All right. That worked. It created a transaction. You can see that we paid gas whenever this happened because our balance went down. And we can get the count again. And boom, there you go. It's 1. Okay. So now I want to refactor this code to make it better. So refactor just means to change and simplify. So in this case, what I'm going to do is change this right here inside the increment count function. Instead of saying count equals count plus 1, you can do that in Solidity just like this. You can basically just take the count variable and go count plus plus. All right. And then that will increment the count by 1. That's what the plus plus or increment operator means. So next we can get rid of this function entirely. So I'll show you how. Well, essentially, whenever we create this uint, we can assign it public visibility like this, uint public count. And whenever we do this, Solidity is going to give us a function called count for free. It's going to expose it outside the smart contract so we can just call a count function and remove the need of creating our own get count function entirely. Okay, so I can just literally delete that because now we can call a function called count, which Solidity is going to expose for free once we do this. All right, and the next thing that I can do is also get rid of this constructor function entirely, okay, because Solidity lets you set default values for these state variables in line. So I can literally just say public count equals 0, all right, and then get rid of this. But that demonstrates, I wanted to do those things first to demonstrate the other functionality of Solidity and introduce those concepts before we simplify things like this. So you can make it 1, you can make it 2, but let's just start with 0. All right, now let's go back to the process of compilation and deployment. So click compile, and now we have no warnings anymore because there's no constructor for it to yell at us about. And then we do deploy. Okay, and then actually I'm just going to delete all these and then click deploy again just to make things less confusing. You see the count is 0, and then we can do increment count, and then boom, there you go. The count is 1. All right, so now let's talk about variables and data types. So make sure you're over at remix.ethereum.org to follow along with this section. And what we're going to do is create a new smart contract inside of here. We'll go to the contracts directory and click this new contract icon right here. And we'll create a contract called my contract, capital M, Y, capital C, contract.sol. All right. And then inside of here, we're going to declare the Solidity programming language version. We can literally just copy this line from the previous example. All right. And then paste it in here with the license identifier. And then we can say contract, my contract, and then use the curly braces. And then we'll write all the code inside of here. Okay. So now let's talk about variables. All right. So what are they? Well, essentially variables are just ways to store information inside your smart contract that you can reuse later. So, we saw that functions were basically like snippets of code that you could run over and over again, reuse later. Variables is just data that you can store and reuse later. So we're going to talk about state variables versus local variables. So I made a brief mention of state variables in the last video, or the last section, I should say. But now let's talk about local variables, and then we'll get back to state variables. So basically, local variables are just variables that exist inside of Solidity functions. So you can see an example like this. We could say function, get value, like we did in the last section. Say public, okay. And then inside of here, we could have a value like this, value, and then it can return value. And we can set this value to an unsigned integer like this, uint, let's see here, value equals 1, okay. And so value in this case is just a local variable. So that basically means a variable that is declared and assigned and used only inside of this particular function. So that also has several implications, which means you can't read this variable value inside of any other function except get value. Okay, you can't access it up here as a state variable, and you can't call it from another function at all. So that's called the variable scope, which just determines like where the variable can be read, where it can be updated, and all that type of stuff. So, whenever we've assigned the value of value here, we can do anything we want to with that. We can do math with it. All right. We can do -1. We could, read the value, say value equals value plus 1, right? We can do lots of stuff. We can read it and we can assign it again, and we can also just simply return it. And now let's just finish this function off like this. We'll just say public, and we'll say pure returns uint. Okay. And we want to have this be public because we want to call it outside the smart contract. So I already did that. But pure because it doesn't modify the blockchain in any way. It just fetches information, doesn't mutate anything. And then, of course, it returns this data type, which is what uint is. So that's what a local variable is, and we're going to read it out with this function. Let's talk about a state variable and how that's different. So I can create a state variable like this that's basically the same thing. We can just say, we'll call it uint, my uint, and we'll say equals 1. So essentially, this is doing the exact same thing with a different name, but we're just creating an unsigned integer here with the value of 1. So this is a state variable, which is different from a local variable because this variable value is stored on the blockchain. Again, whenever we save information to the blockchain, we create transactions, we have to pay gas, and this is saved forever. So we can also update this, and every time we update it, it will also get saved to the blockchain. So again, an unsigned integer is just a data type. It's a number. It's an integer without a sign, so it can't be negative. So that won't work. It has to be 1, 2, 3. It can't be -1, -2. No sign in front of it. Okay. And the other thing I'll say about this variable, this state variable, is the scope. So again, the scope is basically where you can access this variable, where you can update it. So this variable has scope inside the entire smart contract. So if we had another state variable, we could access it there. We can access it inside this function. Okay, if we had any other function, we can read its value inside of there, and we can also update the value inside of any function because this variable has scope within the entire contract. Okay, so now let's talk about some different data types inside Solidity. We've covered the basics of the variables, and now we're going to create some new variables of different data types. So here we've just added an unsigned integer, and we've assigned it to 1. So let's go ahead and call this public so we can read it out to the smart contract if we want to. But now let's talk about some other unsigned integers. So I can do this. I can say uint 256. So my uint 256. I say public equals 1. And so what is that? Well, essentially, uint is short for unsigned integer 256. So 256 is the number of bytes that are actually stored in the number. Okay, we're going to see some more uints here in a minute. This is the default size for unsigned integers in Solidity, and for that reason, you can just use uint for shorthand, and this will give you a uint 256. So this is literally the exact same thing. This is just short for this. So we can use smaller uints like this. So uint 8 public, uint 8 equals 1. And lots of other sizes, but this is a really common one. And here inside the Solidity documentation, you can see that Solidity supports both signed and signed integers of various sizes. Keywords uint 8 to uint 256 and steps of 8. Okay, so you can say all these different sizes just like this, 32, etc., 16. All right. And so let's look at a couple of those. We also want to look at ints, so not just unsigned integers, but we can also do ints like this. Okay, we can basically say int 256, my int equals 1. So this is an integer, but it could also be negative if we wanted to. So this is an unsigned integer, it cannot be negative, and this is an int, and we could have this of different sizes. We could have int 8, or I could have int without any type of number that would, imply int 256 as well. So one might ask, why do you have different types of ints? Okay, well, it's because you care about the size of information that you're putting on the smart contract and on the blockchain. So basically, this is going to be a smaller integer. Okay, and sometimes you only want to allow, data that's of this size versus data of this size, which is going to be a lot bigger. Okay. So, by default, for most general purposes, 256 is going to be fine like this for, just general, tutorial programming projects. When you get into production smart contracts, you probably want to start considering different sizes depending on the footprint that you're trying to save. And next, we can do strings. So what are strings? Well, they're just groupings of characters inside of quotation marks like this. So it could be a word, cat, it could be another word, dog, or it could be a sentence. My cat looks like a dog. Okay. As long as you can fit the characters inside of the quotation marks, it'll work for a string. So we can create a string in Solidity like this. We can give it the string keyword because again, it's statically typed. So string, we'll say my string equals hello world. Okay. And then we're going to finish that with a semicolon like this. All right. And then we can also call this public. So we can read out the smart contract, say string public. And we'll also make these other variables public as well. Public. I'm going to move them before. My fault. I accidentally put them after. All right. That reads a lot nicer. I also realized that I didn't make this my uint 8. Sorry. My brain is just not working right now. So anyways, now let's look at another string. We'll do a bytes 32 string like this. We'll say bytes 32 public my bytes 32 equals hello world. All right. And so what this is it lets you store a string in a bytes 32 format, which basically treats your string more like an array and gives you some different flexibility that you don't have with the regular string. Okay. So you'll definitely see example use cases of this out in the wild. Next, we can store addresses inside of variables inside Solidity like this. So we can say address. All right. Public. And we can say my address. Okay. And then I'm actually just going to paste an address inside of here. Okay. Like this. Boom. So what is an address? Well, an address is sort of like a username on the blockchain. Okay. And it corresponds to an address for, a user account, like if you have your MetaMask wallet connected, or it, corresponds to a smart contract address. So any contract on the network is going to have a address, and any user connected to the network, any wallet is going to have an address associated with it, and we can store those for reuse, whatever purpose we want to, inside Solidity variables with the address data type, just like this. All right, so the last thing I want to talk about are structs. So we've seen different types of variables and different data types like strings, numbers, addresses. But the cool thing about Solidity is that it lets you create your own custom data types with structs. So, if you want to create something that's more sophisticated than just a simple number or a simple string or a simple address or any of the other basic data types, you can do that with structs like this. We'll say struct, keyword, we can call it my struct. Okay. And inside of here, we can basically create a complex object that has multiple, values inside of it. So we can say, uint 256, my uint 256. And then string, my string. Okay. And so this just defines the struct. So, we don't need to define a string or an address because these are already, defined at the Solidity compiler level. But if we're going to create our own custom structs, we have to define it first like this. Now we haven't actually created an instance of my struct yet, but we can do that like this. We can say, my struct public, and then say my struct equals my struct, and then say 1, and then hello world. Okay. And then that's going to actually create the instance of my struct, because again, whenever we create a variable, we give it the data type first. We create the data type of my struct here. So this data type, it's public. We give it the variable name, my struct, and then we instantiate the struct by, just saying the name my struct followed by these parentheses, and then we pass in the first value of the struct, which is my uint 256. Okay, so it's an unsigned integer. This is an unsigned integer. And then the second value is a string, my string. And then this is the string that we pass in right there. All right, so let's go ahead and save all this and compile it. And compile and run. And it looks like we got a little bit of error here. Let's just fix that. So my fault, I put a comma, just a bad habit. We need to put semicolons here. All right, sometimes it's a lot harder to code and talk than you might think. So this is real life software development, everybody. I like keeping these errors on screen because it keeps things real. So we'll do compile, and then we'll go to deploy. That also happens when you have multiple programming languages. So we'll say deploy. Okay, and now the context to deploy the network, we can see the transaction here, and then we can see the value of these different things. So get value, all right, it's equal to 1. Okay, we can see my address, all right, bytes 32. You can actually see the bytes 32 format returned here my int is 1, my string, hello world, my struct. And here you can see how Solidity compiler handles structs. It gives you two different values. The first value is 0. The second value is 1. Okay. And then my uint is 1. All right. And there we go. All right, now let's talk about arrays. So I'm going to take the code from the last video, or the last section, I should say, and clear it out. So we're going to keep my contract inside of here, but we're going to just take out the guts from the middle. We're going to add our code here. So let's talk about arrays. What are they? Well, essentially, they are just sorted groupings of different pieces of data. So that's probably not the best computer science definition, but you'll see what I mean here in a second. So basically, we're going to say arrays, all right? And let's just go ahead and create our first array so that you can see what I'm talking about. I'm going to say uint, and then I'm going to give these brackets like this, say public, and then uint array, and then we'll say 1, 2, 3, and followed by a semicolon. So let's just illustrate the concept so that you can understand what it is. Well, an array here is this. All right, you can see it's these brackets, beginning bracket and closing bracket. So array really is just a list, and it's a list of numbers sort of separated by commas. So 1, 2, 3. These are 3 different items or elements inside this array, and they are sorted. They're in order. The order shouldn't change. And really, this is just a way of keeping things inside of a group that we want to pass around and use inside of our smart contract. Okay. So if you're a programmer already, you definitely probably understand what arrays are, but if you're brand new, I just want to explain that concept. Now, with Solidity, we declare the data type for an array like this. Again, anytime you're creating a variable like this, we're storing the array to a variable, we're calling it public, you have to declare the type. So for arrays, we do that like this. We tell it the data that's inside of the array first. So this is an array of unsigned integers. So we say uint. And then we give it the curly brackets, it's not the curly brackets, the brackets here that tell it that it is an array. So this means this is what's inside of the array, and this tells it that it's an array. So this reads like an array of unsigned integers. This is the array of unsigned integers, and then we're storing it to this variable called uint array right here. We also create arrays of different data types like strings. We could say a string array, okay, and then give it like this and say public string array. Okay, and then we can say, apple, banana, carrot. Okay, so this is another array, just has different data type inside of it. You get a string here. We can also just create new arrays that are empty. We can say string array and say public, my array. Okay. Okay, so now let's talk about how to manipulate arrays inside Solidity, because now that we've created these state variables, we could modify them inside of any function that we want to. So let's go ahead and create a function that's going to modify this variable value right here. So let's actually update this. We'll just call this value, not my array. And we're going to create a function right here called add value. So we'll say function add value, and it's going to give it one argument. We'll say string memory value. We're going to pass in a value here, and we'll call this public. Okay. And then inside of here, what we're going to do is say values. That's this right here. And we say push and the underscore value. So let's explain that. So value, of course, is passed into the function. And then values is this array right here. And then what push does is push adds a new item into the array at the last position. So basically, if you passed in the word, donkey or something like that, it would add the word donkey to the end of this array. Okay. So that's what the push function does, and it keeps the array sorted. And again, this is a local variable. It's being passed in Solidity. This is a state variable. So whenever we call this function, it's actually going to update this array on the blockchain itself and save it. And we'll have to pay gas whenever we call this function. So let's talk about another thing that we can do. We can get the length of the array. So we can work with another function here. So we could say function value. We say value count. Okay, we're just going to count the number of items inside this array. And we'll say public view returns uint. All right, and inside of here, what we're going to do, say return values.length. All right, so what that's going to do is take this and then actually get the number of items inside of it. That's what the length is. So length is just going to return 3 in this case. If we had added another one in that last function, it's going to return 4, so on and so forth. We can observe that behavior in our, our tools over here after we deploy it. So the last thing I want to talk about are two-dimensional arrays. So what is that? Well, a two-dimensional array is basically just an array inside of another array. So an array of arrays is another way of thinking about that. And you can do that with Solidity like this. You can say uint 256. All right, so this is going to be an array of unsigned integers inside of another array. Okay, so we'll call it public 2D. We'll say array 2D because you don't want to start Solidity variables with numbers. And then we're just going to say, an array of arrays. So the inside array is going to be 1, 2, 3, and then we'll say 4, 5, 6, and then we'll end that with a semicolon, just like this. All right, it looks like it's yelling at me here, but hopefully this should work. Let's add some space here. It's probably cleaner. Let's do that here too. All right, so we're not just all clumped up in there. But one thing I do want to do is update this. I realized that values is not defined, so we actually need to make this values plural here. So sorry about that, everybody. All right, so values push value, values length. All right. So let's go back here and we're going to compile. And then, all right, it works. So this is fine. Let's go ahead and deploy it and click deploy and see my contract. Okay. So we can see so start with the value count is 0. We can add a value like this. We'll just say foobar. Okay, give it a string, click add value, and we can see this here. And now we can read the values count. Okay, it's 1, and we can actually read the values from the array. So what I'll say here is whenever you're reading from this public variable and you call values, it's not going to return the entire array itself. Okay, it's going to give you a function where you access each individual item out of the array. So that's why it's really important to understand the length of the entire array, and that's why we use values count here. So these arrays are 0-based index, which means that the first item in the array is 0, the second item is 1, etc., etc. So if I do value 0, it's not going to return anything here. Okay, what I want to do is type in values 0 to actually get that first item because there's only 1 inside of there, and boom, there you go. You can see the string is foobar. Okay, we can also see the uint array, string array. We can get the first item here. All right, apple. Second item is, number 1. Third item is number 2. All right, a 2-day array. Basically, with this, what you want to do is you can use this menu here to get 2 inputs, and it's going to have 2 arguments. So the first argument is going to be the index of the first array. So 0. 0 is going to be 0, 0, this number here. So it should be 1. All right. And then 0, 1 should be this number here, 2. All right, but if I do, 1 is going to be the second array, and then the first item in that array is going to be 0. Okay, and then 1 should be the first item in that list. It should be this. Okay, awesome. So same thing for the uint array. I'll leave those up to you as an exercise. All right, so that's an overview of how arrays work inside Solidity, and I'll catch you in that next section. All right, so now let's talk about mappings inside of Solidity. So what are they? Well, they are a data type that lets you store data on the blockchain with key value pairs. So what is that? Well, key value pairs are common in many programming languages where you have things like a hash or a hash table or an associative array. And they're also really common inside of traditional databases like MySQL, Postgres, where you have an ID that corresponds to a data record, where you have a unique key that corresponds to one unique value, or maybe like MongoDB, for example. So you have a key here, first name, and anytime you look inside this key value pair, first name always corresponds to this value bugs. And then you have last name that always corresponds to this value bunny. Okay, so if you update first name, it's going to change this. And if you read first name, it's going to change, read this and nothing else. So you can create a mapping inside Solidity like this. So you can just say, mapping keyword. All right, that's going to create a new mapping. And then you give it the key value pair. So key and then value. I'm just using these names to illustrate it. We'll change these in a minute. But the key goes here. The value goes here. And we can call this, you give the name of the mapping like this. We can call it my mapping. Okay. So that's what a basic mapping would look like. And we can use this to write data to the blockchain, since this is a state variable. And we can treat the blockchain like a database in this way, where we give it a key, which is kind of like the ID, and then the value, which is, whatever information we're storing to the blockchain itself. So let's create a mapping of names to make this really simple. Okay. So this will make it less abstract. So we'll create a names mapping. All right, kind of like we just saw in this key value pair here. So let's do this. We'll say give it a uint. That'll be the data type for the key. So it'll be like an ID, and the value will be a string. All right, so the key data type is uint, and the value data type is string. So we can assign stuff to the mapping like this. We'll create a constructor function, constructor. Again, this is the function that's run once and only once whenever the smart contract's deployed to the blockchain. And we can add items to the mapping like this. We can say names and then use these curly brackets to either access information from the mapping or write information to it. So we can add a name here to the ID 1 or the key 1, this unsigned integer. And we can say this is equal to Adam. All right. And then we can do it again. We can say names 2 is equal to Bruce. And the names 3 is equal to Carl. All right. And that's how you add information to a mapping. All right, so now what I want to do is show you how you can use mappings to make the blockchain actually work like a database where you can store complex data. So in this case, we're just storing a mapping of unsigned integers that have a value of strings. This is pretty simple data. But we can make this much more complex and make it work like a traditional database with structs. So remember, we talked about structs in that last section. Definitely go check that out if you haven't already. We can create a new struct like this. We can call it book. So this is our own custom data structure. We just call the struct keyword here, and we give it the name book, and we give it a string title, okay, and then a string author, okay. So it's going to have two attributes here, title and author, and we can create a theoretical database of books on the blockchain with a mapping. So this will be like our database, table essentially, where we have these different columns, like a column for title and a column for author, and then we kind of have an imaginary column for, the ID with this mapping. So we'll create the mapping like this, mapping. We'll say uint, and then we give the data type. We can give it our custom defined struct data type here of book. All right. And then we can say public books, and will this be the books mapping? So let's see how we can add a book to the mapping like this. So we'll go down here and we'll create a function that says function add book, and then we'll give it some arguments here. Say uint 256, or you can say uint for short, underscore ID. All right, a string memory title, and then string memory author. And we can call this public because we want to call out to the function. And then we want to add the book inside of here. So how do we do that? Well, again, we say the name of the mapping here, then we give it the curly braces, and we give it the, the key that we want to assign it to. So we say books, which is the name of the mapping. Okay. And then we give it the curly braces, and we add ID, which is this ID here, underscore. And then we say equals book. Okay. Like this, book. And then title, and then author. Okay. So I want to call out something here. These arguments here are local variables. We talked about the difference between local variables and state variables. Again, local variables are only accessible inside this function. They're not accessible anywhere else inside this contract. And I'm using a convention of underscores in front of the local variables just as a convention. These are not required inside Solidity, but it helps differentiate between local variables and state variables. And it's a common thing that Solidity developers do. So I'm also going to format this function. I'll show you a cool way to do that. We can break the lines up here. So after each argument, we can go to a new line so that we can save some horizontal space. And then we can have our add book function just like this. All right. So we're going to read this out in a minute whenever we compile the contract and deploy it. But now I want to show you one more cool thing with mappings before we do that, which is you can create nested mappings. So just like we saw in the last video where we had, an array of arrays, that's a 2D array or a nested array. Similarly, we can have a mapping of mappings. All right. So why would you want to do this? Well, this is really common for things like tokens and NFTs. You see this pattern all the time where you want to see a balance that's nested under a particular, user account. In a very similar way, we can, create a mapping of books that correspond to a particular, Ethereum address. So we can create that nested mapping like this. Okay. So basically we'll just take the book mapping. Okay. Book. And we'll put it inside of another mapping. So the key, so we'll say mapping. The key is an address. And then the value is just another mapping. All right. And we'll call this public my books. So think about it's kind of like a library where, you have all the books in the database here, but then you want to see my particular books. The key is going to be the address of the person who owns the book. And then the mapping is going to be, the value is going to be another mapping of all the books that belong to this particular account. All right. So let's talk about how to add this to the mapping. So instead of add book, we'll just copy this and then paste it here. We'll say add my book. Okay, so it's got the same arguments, the ID, title, author, but instead of, books ID, we'll say my books, and then we'll pass it another key for this one, and we'll say message.sender. So what is this message sender? Well, Solidity has something called a global variable called message. Again, we talked about state variables and then local variables. We also have global variables, which are just exposed by Solidity in every single smart contract available on the blockchain. So message.sender, so message has a value or a key called sender. So you can do message.sender, and that's going to be the person who's calling the smart contract. So it's going to be the Ethereum address of the person who calls add my book. So that will be their address. That can be the key, which we add here. And then we create a second key for the nested mapping for the ID of the book, and then title and author for the book struct. Now we can compile this and see all this in action. Okay, I'm just going to reduce the font size here so we can kind of see it. And we'll go to our compilation tab here. And we'll compile, see if there's any warnings. So it looks like there's a warning here. So this constructor, visibility for constructor is ignored. Let's just take this off. Okay. And then we'll go to deploy. And then we'll click deploy. And there we go. So now we can interact with the smart contract like this. We can basically create, well, first of all, let's look at the names. All right. So actually, let's make it public first. So let's run through the steps again. Public. Let's read values from the mapping. So we'll go back and recompile. And then we'll go to deploy. Let's delete this. Click deploy. And now we can read items from the names mapping. All right, so here's names. So now we can basically see that to read items out of the mapping, we just give it the key inside this function right here. So I'll pull this up in case it's cutting off on the screen. And we'll give it an ID like this. So we'll just say 1. So names 1. Like this should return Adam. And there you go. Boom. String Adam. And 2. Names Bruce. Awesome. So we can do the same thing for books and my book, but we don't have any books yet. So let's add a book. Let's give an ID of 1. And then say title is, The Great Gatsby. And we can say author is Fitzgerald. Okay. Then click transact. Of course, you have to pay gas to do that. You'll see your ether balance go down. And we can read my books, books, ID 1. And then boom, The Great Gatsby, Fitzgerald. Books ID 2. And we can say, let's see, A Tale of Two Cities. And we say Dickens. Click transact. And then books 2. And then boom, there you go. Actually, that didn't work. Let's do books 2. I forgot to do the ID, so we overwrote that. Tale of Two Cities, Dickens. Awesome. And I think we actually overwrote it, so it's going to be the same for book 1. Yeah. Oops. Oh, well. All right. So next, let's talk about adding my book. So here you can see that we can do ID 1. Let's see, title. Let's just say, let's come up with another book. Say Lord of the Rings. Or let's do The Hobbit. And we can say Tolkien. All right, click transact. And then we can go to My Books. So how do we read that? Well, essentially we need the address. So we can copy the address from Remix here. Click copy. And then we can paste in the ID like this. And then boom, there you go. The Hobbit by Tolkien. And so, again, we were acting as this account. So message.sender is going to be read from the transaction. All right. And the transaction, the person who created the transaction is this account here. So it's automatically going to get the address from here. We don't have to pass it into the function. Okay, so that's an overview of the basics for Solidity mappings. Okay, so now let's talk about conditionals and loops. So these are two things you need to understand inside of Solidity. So we'll start off with conditionals. So what are those? Well, a conditionals was called a control flow structure. Okay, so basically that means it's just a logic gate inside of programming that says, hey, if this, then that. All right, so basically you have an if statement. So if, some condition, okay, then do some action, and else do some other action. And you don't even have to have the else clause, but basically this is the idea. If this is true, then do this. If else, do something else, okay? So an example would be, if you had a number here, 1, so if, I'm just going to do some pseudocode here. If 1, is even, this is literally just pseudocode. This is not real Solidity code. You can say, then console.log, number is even. Okay. Again, this is not real Solidity code, just an example to show you. Else, console.log, and Solidity doesn't even have console.log out of the box, just so you know. Number is odd. Okay. So this is an example. So we'll kind of code this out with real Solidity code. So what we're going to do is basically take an array, all right, of numbers and see if they are even or odd, just like we saw in that pseudocode example. So we'll take it. We'll start with an array. We covered these already in the previous section, so go check that out if you haven't already. Say uint an array of unsigned integers. We'll say public numbers equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, use a semicolon here. And what we're going to do is create a function that, evaluates a number and sees if that number is even or odd. So we'll say function is even number. I'm going to pass in a number, uint number. And we'll say public view returns Boolean, bool. So that's just a true or false value. That's what a Boolean is, just true or false. And then inside of here, we're going to create a conditional. So we'll say if number that we're passing in here, modulo 2 is equal to 0, then return true, else return false. Okay. So let's break that down. So first of all, we have this conditional. This is what it looks like. So if, and then you put in your condition inside of here. That's the condition for the conditional. If this condition is met, if it returns true, then do whatever's inside of this line of code. All right. So in this case, we're just going to return true from this function. That's the return value of bool. Else, do whatever's inside of this part of the code, which is, return false. Okay. So, let's talk about the condition itself. So how do we check if a number is even? Well, we use this thing called the modulo operator, which basically takes a number and divides it, and it gets the remainder. So the remainder is like this. So, 5, modulo, 2 is going to equal 1, because if you divide 5 by 2, it's going to be 2 remainder 1, right? If you do, 10 modulo 2, it's going to be 0 because 10 is divisible by 2, but 5 is not divisible by 2. You divide by 2 and you get a remainder of 1. Okay. So, the number in this case, if it's 5 modulo 2 is going to equal 1, so it's going to be false. If you pass in 10 here, it's going to be modulo remainder is equal to 0, so it's going to return true. Because any even number, all right, is essentially going to be divisible by 2, and that's how you check. All right, so that's how we do a conditional. You can see it here. That covers the conditional side of things. Now let's talk about loops. So we're not actually going to use this array for the is-even number function. We'll just pass in our arbitrary number when we demonstrate this here in a second. But what we can do now is create a function that uses a loop. So what is a loop? Well, a loop is something that takes over an iterative data structure like an array, which has multiple items in it. You can iterate over this array, you can loop through it, and then perform an action on each item in the array. So there's 10 items here, numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we can create a loop that checks each of these items, inside the array to see if it's even. So we did a function here that uses conditional to see if it's even. And we can use a conditional inside of a loop with a function like this. We can say function count even numbers. Okay. And we say public view returns uint. So it's going to return the count. It's going to tell me how many even numbers are inside of here. In this case, it's going to be, 5, 1, 2, 3, 4, 5. And I realized we skipped 5. Sorry, everybody. A little tired. 2, 1, 2, 3, 4, 5. Okay, you probably saw that. I'm sure you've been wondering when I was going to add 5 there. Here we are. So I'll show you how we do the loop. So first of all, we're going to create a variable called count. Say uint count equals 0. And then now we're going to create the loop like this. So we're going to use something called a for loop. So a for loop, what it does is it uses an iterator to iterate over each item inside of a collection like this. So we say for, all right, and then this is what we do inside the loop, but we pass the condition for the for loop here. We say uint equal I. Okay, we declare a variable I equals 0. And then we say I is less than numbers.length. Okay, and then I plus plus. All right, so what does this do? Well, basically, we start off with something, we start off in the loop with a counter variable. So that's what this I is. This is really common in other programming languages where you start with a number of 0, and you say, starting from the number 0, all the way up to the number's length, all right, which in this case is going to be up to 10, check, run the loop every single time until you get to this condition is satisfied. So you start with 0, and then the first time it runs, I is going to be 0. And then whenever we finish the loop, we're going to increment this value. That's what this is. So basically, here's what we start off with. Here's the condition at which it stops running. Okay. And then here is the value that we increase this number. So basically, what we're going to do is, we're going to, first of all, we're going to say count. We're going to loop through them like this. We'll say if is even number. And then we're going to use this function that we created here. And we'll say numbers I. So we're going to read the number out of this array like this. We're going to pass in this function we just created to check if it's even. Okay, so if it's an even number, then we will just increment the count plus plus. So we're starting off the count here as 0. So to count the even numbers, we start off with 0. We loop through each number in the array. And if it's even, then we increment the count, this count right here, with this line. And then whenever it's done, we're going to return count. All right. And so let's go ahead and just test this out to see if this is working so far. There's one more conditional I want to add, but basically what I also want to illustrate is you can do conditionals that have, if-else statements here, like if and else. But this condition right here has no else statement. All right. It's just an if, because we don't want to do anything else. Right. We just want to skip and continue on if there's no, we don't care about an else statement. So here, let's compile just to make sure it compiles okay. All right. So let's see here. We can just ignore this for now. We'll fix it in a second. And then we'll go to deploy. Now let's just make sure it works okay. And so we'll do the count even numbers, and it returns 5. So that's what we expect. There's 5, 1, 2, 3, 4, 5. So this is working. And then let's see, is number even? All right. We can see if number's even. 1. So false. Number 2 is true. 100 is also true. And 99 should be false. All right. So that's working. We can also read the numbers from the mapping, from the array like this. Okay, awesome. All right, so the last thing I want to show you is how to use a quick one-liner to check something is true or false rather than having to do this if-else statement all the time. It's like a one-liner, okay? So what we're going to do is basically create an owner for the smart contract. So what's that mean? So we'll say constructor. Again, this is the function that's going to get called where the smart contract's put on the blockchain. We talked about message sender. All right, in the last section about how this is the person who's calling the function. In this case, this is going to be the contract that deploys the account that deploys the contract to the network. And we can assign it to a variable called owner. Okay, and then we can make this a state variable for the entire contract like this. We can just say address public owner. So this is really common to have ownable smart contracts where somebody has special privileges inside the smart contract. So ownable contracts is definitely a pattern that's important to understand when coding Solidity smart contracts. So here's the owner, the person who deployed it. And what we're going to do is create a function here that checks if the current address is the owner. So we say function is owner, and this is really common in smart contracts. Say public view returns, and then bool. And then we'll say return message to sender, the person who's calling this function, not the constructor. We'll say is it equal. So we use double equal sign. I'm thinking JavaScript here. Again, sometimes when you code multiple programming languages, you get things a little mixed up the first time. But again, double equals checks for equality, just like we have here. It doesn't assign anything. We're not assigning message sender to anything. We're just checking to see if two values are equal. And we say owner. So this is a quick one-liner to check to see if something is true or false. We just return message sender is equal to the owner, and that will return true. If the caller of this function is the owner of the contract, it'll return false if not. So now let's check that. Let's go to let's deploy again. Well, let's make sure it compiles properly. I can't remember how Remix does this, but sometimes I just do it over again just to make sure. And then now we can say is owner true. And we can change to a different account here and say is owner, and it's false. Okay, so that's a quick overview of conditionals and loops. Okay, so up until this point, we have covered different aspects of Solidity programming language, like variables, data structures, different types of functions. And in this video, what we're going to do is move away from individual features of the programming language and put a lot of things together by coding out a complete smart contract that actually does something. Okay, it's a little bit different approach. And so along the way, we're going to create a new contract here called Hotel Room, and it's going to teach us about the following concepts: how to pay with cryptocurrency inside of smart contracts, how to actually send Ether around or whatever the native cryptocurrency is of your blockchain, how to use function modifiers, okay, how to set the visibility of a function, how to work with Solidity events, and also enums. So don't worry if you don't understand exactly what all these things mean before we get started. You're going to see those along the way and learn how to apply them to your own smart contracts. So what are we going to create here? We're going to create a new smart contract called Hotel Room. All right, so go ahead and create that over here in your file browser if you haven't already. Capital H, capital R, hotelroom.sol. And, you can start off with the same, programming language version that we did in the previous sections. Just create a new contract called Hotel Room. And so what's it going to do? Well, essentially, it's going to be responsible for booking a hotel room and opening it. So someone, when they want to book the hotel room, they'll pay for it with cryptocurrency. They'll do it with Ether. I'll show you how to send Ether to the smart contract. And then whenever you do that, it's going to handle the booking. It'll work kind of like a vending machine in this way. That's kind of like what smart contracts are. Once you put them on the blockchain, they just do something whenever you interact with them, like send money. All right, so now let's code out the first bit of functionality for this particular smart contract. We want to create a new function here. We're going to call it book. Okay. And it's going to be like book the hotel room, not like a book like you read the book. And what we're going to do here is pay the person who created this smart contract, who's going to be the hotel room owner, and then actually book the hotel room so that it's open and they can, use it. So what we want to do is model the owner of the hotel room or the smart contract. So we can do that with a state variable here. All right, we can say address, payable, and say public owner. All right, so this is a state variable. It's going to be the Ethereum address of the person who created this smart contract who owns the hotel room. And we want it to be public so we can read this value outside of the smart contract on the blockchain. And then we also want it to be payable. All right, this is a specific modifier. That's what we said earlier. We're talking about modifiers. A modifier that lets this address actually receive Ethereum cryptocurrency, which we'll see in a minute. So we're going to save this owner. All right, we could just assign it here. We could say equals and then 0x blah 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 blah, and we could hard code in an address, but that's not really what we want to do. We want it to be dynamic, so we want it to be the address that actually puts this smart contract in the blockchain, no matter who it is. So we'll use the constructor function for that. So say constructor. All right, and inside of here, what we're going to do is say owner equals message msg.sender. So again, message is a global variable inside Solidity, and sender is a property on that message that tells us, who is calling this function, who is deploying this contract to the blockchain, because that's what the constructor function is. It's a special function that gets run once and only once whenever we put this contract on the network when the contract's created. So then we save owner is the state variable here. So now let's actually do something inside of the booking function, okay? So the first thing we want to do is pay the owner. So we want to pay the owner of the hotel room in order to, actually open it. So we do that like this. We'll have, inside of our book function, we'll say owner transfer, and then we'll pass in message.value, and then use a semicolon here. So let's talk about the transfer function. What does it do? Well, it sends cryptocurrency to the recipient. In this case, it's the owner. All right. And so where does the cryptocurrency come from? Well, it comes from the person who's calling the book function. So as we'll see here in a minute, whenever we go here and compile the contract and run it, you can send cryptocurrency whenever you call a function. So if you had your MetaMask wallet out or something, or you're interacting with this website, you could call this book function and it'll say, do you want to call the book function? And you tell it yes. But it'll also say, hey, you need to send in some cryptocurrency, some ether in this case, whenever you call the book function, okay? And inside the transaction and inside the Solidity smart contract, that amount of cryptocurrency that you're sending in is going to be stored with another global variable, message value. So we have message sender, who is the person who's calling the smart contract, and then we have message value, which is the amount of ether or cryptocurrency sent in whenever you call this function, okay? So what we're saying is message value, the amount of ether that's sent in, send it or transfer it to the owner, which is this address here, which we've made payable. Now, one other thing we need to do this function in order to make this work, where we can actually work with message value, is also make this function payable. All right, because we had the address, the owner is payable, and then now we have the address. Now we also need to have the book function payable so we can actually send Ethereum cryptocurrency and or ether and then use it inside the function here. All right, so now that we have paid the owner, we want to update the status of the hotel room from vacant to occupied. Okay, so I'll put some comments here. All right, and that's basically going to let us know whether somebody's in the hotel room or not, or whether somebody has booked it. So we're going to use something called an enum to track this. So what is that? Well, let me just write it out and then I'll explain how it works. We'll say enum statuses, and then we'll use these curly braces like this. We'll say vacant or occupied. All right, so an enum is a data structure inside of Solidity, and we can give it a name. So what is it? Well, basically an enum is just a collection of options that's never going to change. So we see have these options that we've coded out inside of here. So vacant and occupied. You can think about, it's perfect for keeping track of statuses or states. A hotel room occupancy is a perfect example of this. Is a hotel room empty, or is it, somebody in there, vacant and occupied? And that's a status of a hotel room. It's the state. So an enum is the perfect data structure for this. So we can say enum and give it a name, statuses. And then we can also create a variable that keeps track of the current status. So we'll basically just say statuses and then current status. Okay, so basically current status is going to use the status as enum to find out what the current status is. And we can set the default status. We can set current status. Whenever we deploy the contract like this, we can say current status equals statuses vacant. All right, so this is how you read the value from enum. You just say status is vacant, which is this, and then current status equals status is vacant. These are the options, and then this is the current status. So this is really the thing we're checking against and setting, but these are all the options that we have to choose from, so that you can't use like some other option, and it'll always correspond to the return value of the vacant here. Okay. And now the next thing we do when we call the book function is we want to occupy the hotel room. So we can say current status equals statuses occupied. Okay. So that will handle the booking. So now I know that whenever you book a hotel room, it doesn't automatically occupy. Okay. So I know that's a little bit confusing, naming here, but we'll address that here in a minute. All right. So now what we want to do is add more features to this book function, or add more logic, I should say, to this book function. Because right now there's some problems, like this hotel room could potentially be booked twice. Okay. We don't know how much it costs. We need to require some sort of price. So let's do that right now. So inside of here, what we want to do is check price, because we want to, assign a price to the hotel room so we can book it. And then we also want to, check the status. Essentially, we want to make sure that you can't book it twice if it's already occupied. So how are we going to do that? Well, let's do the status first. So essentially, Solidity gives us a special function called require. All right. That is, just provided by Solidity for free. We don't define the function require. It just comes for free with the programming language. And it has a special functionality. So anytime you put require function inside of another function like book, it just checks a statement to see whether it's true or whether it's false. Okay. So I can put some stuff inside of here like 1 + 1 = 2. All right. This is an expression and it evaluates to true. And basically it just says require that this is true. And if this satisfies, if it's true, it passes, then it continues execution on these other lines. Now, if I said 2 + 2 = 3, all right, that's going to equal false. And this is going to say, hey, that's false. So stop function execution and don't run these other lines of code. Okay, so if it's true, then the other lines of code run. If it's false, then the other lines of code don't run. So let's check that. We can check the status to see whether it's true or false and satisfies those conditions so that we can run this code or not. So basically what we want to do is if the hotel room is already occupied, we don't want to update the status to occupied, and we don't want to send money to the owner. So we can do that like this. We can say current status, and then we say equals statuses dot occupied. Or sorry, statuses dot vacant. Say statuses dot vacant. All right. And so basically, it's going to require that the current status is that the hotel room is empty before we run these other lines in the function. And if this is true, then these will execute. And if status is not vacant, then it'll just stop entirely. So we can give it one more argument here that gives it a message. So I can say currently occupied. All right. And so basically, you can see this is what will surface to the user if we don't have, like, basically this will surface to the user if this fails. All right, so now we can check the price like this. We can say require, and we can say message that value is greater than or equal to 2 ether, and then we can say not enough ether provided. Okay, so what is this? So we're going to check the price. So we're going to say that the hotel room costs 2 ether. You can literally just write that out in Solidity like this. Just give the number 2 an ether, and it'll automatically convert it to the amount of cryptocurrency that you want to check. And message value, again, is the amount of cryptocurrency sent in with the transaction, which we saw right here. And we want to say, hey, make sure that's greater than or equal to to Ether, and that's the price. So if they have at least sent in the amount of the price, then we want to continue function execution. And if not, then we just want to halt execution and refund the Ether to the user that was sent in and stop calling the function, and then just tell them like not enough Ether provided. All right, so now I want to show you how you can take these statements right here and create modifiers. So that's the next thing we're going to learn about. So let me just show you what that is and why it's important before we explain exactly what modifiers are. I think just demonstrating it will explain it itself. So just below this constructor function, we're going to create this thing called a modifier. We'll say modifier, and we'll say only while vacant. Okay, and inside of here, what we're going to do is copy this line of code. Okay, and then just do it like this, or cut it, I should say, and then put it inside of here. Take this out. All right, and then we're going to do an additional line here, do an underscore. This is going to return the function code. Okay, so what this is going to do is basically let us take this require statement out and then just add it to the function like this and say payable only while vacant. Okay, so it's a really nice way to clean out the function code and then put it here. Okay, so you don't have too much stuff inside of your code. It doesn't busy things up, and you can also reuse this later on in the Solidity code, right? So similarly, we can do this with the price checking. We can say modifier costs, okay, and then pass in uint amount, all right? And then inside of here, we can just say require and then say message value. Well, let's just copy this, right? We don't need to write it again. Take this out, put it here. Okay. And then I'll show you a cool thing about this. So we can, of course, add, costs here. But what we want to do is actually pass in the amount. So we can just say costs, to Ether. All right. And then pass in the amount here. All right, so only while vacant costs to Ether, we can pass in an arbitrary amount. So message value is greater than or equal to the amount, not enough Ether provided. And then that will check to see if we put in enough right there. Then now I want to add a new line here and do this. Okay. So the last thing I want to do here, and then we're going to clean up some things inside this video. I want to emit an event anytime a booking happens. So what is that? Well, basically, Solidity lets you emit events on a blockchain anytime a particular function is called or anytime that you want to do something inside the blockchain. And what it's going to do is create a log that this event occurred, and you could get an alert about it. So like if somebody booked the hotel room, they could get maybe like an alert on their phone, or, get some, message somewhere else. Okay. Or you could get a history of all the events which took place. Like anytime this hotel room was booked, you could see an entire list of those bookings. So that's the two benefits of events. So I'll show you how that works. We'll create a new event inside Solidity like this. So just above this, we'll say event occupy, and we'll say address occupant, and then uint, we'll say value. All right. And so basically what it's going to do is tell the address of the person who booked the hotel room and then the value that they paid. All right. And so we can call the event. So we just defined the event here, but we need to actually call it inside the function. So we'll do that here and say emit occupy message.sender and then message.value. So this will tell us we can get an alert anytime someone booked the hotel room like this, and we can also see an entire log of the bookings when they take place. Okay, so there are a few things that I want to do to make this code better. All right, so the first thing is go to the top here. Let's just refactor, make this look a little cleaner. I can put these statuses on multiple lines so that we can kind of see the statuses here. All right, and then kind of refactor this. Okay, now one more thing that I want to do is change this line right here. So there can be some issues with the transfer function inside of Solidity. And what I want to do is show you how to use call. So call is another function that we can use to send ether around like this. All right, we can just send a message, but we can also, you can send an arbitrary message to a certain recipient, but we can also send cryptocurrency this way. So what I want to do is say owner instead of transfer. I'm going to send it a message like this and say call. Okay. And then what call is going to do is we can pass in a value. Value is message.value. All right. And then, we could send in something else, but we're just going to leave it an empty string for now. Sorry. All right. And then we can say, we can get the status of that transaction. We can just say bool sent. So this is going to turn true or false of whether it was sent or not. All right. And then bytes, memory, any data that came back. Okay. And so we won't need the data necessarily, but what we're going to do is just make sure that that it actually is sent. And so we can say require true, that we actually we sent the funds to the user and that transaction was successful before we emit this occupy event. And if that doesn't happen, then we can basically stop execution of this transaction. That keeps you from just sending it to the wrong place or, having some issue with the funds being delivered. That's a benefit of using call here over transfer. You can get the status of that and then require that it's true. All right. So that should be everything. All right, let's just kind of take a look here. I think that's it. Let's go try to compile this smart contract and demonstrate everything. So let's go to the compile step. All right, we do have a little bit of issue here. Let's fix this. So we don't need this semicolon here on line 8. It's my fault. It happens sometimes. So we'll just click compile. All right, let's just fix this as well. So basically we forgot to put, let's see here, public here. So public. All right, let's keep going here. And then one more thing is we need to make this payable as well. So this is another feature of Solidity. We want to make sure that this says payable. And then we convert this to payable before we save it as an address payable here. So that's another thing you have to do whenever we're doing that. And then one more thing here is I want to take statuses for current status and make it public because I want to check what the status currently is whenever we compile and deploy the smart contract. So I'm going to minimize some of the font here so we can kind of see the contract while we're, using it. So let's go to our compile tab here and then click compile. And you're going to see, as unused local variable from this. All right, that's what's telling you you're not using this. I wouldn't worry about it just for now. Let's just go here and go ahead and deploy. And let's use the smart contract. So let's check the status. So current status is 0. So that's another thing I want to tell you about enums is basically it tells you the position of each, option in the enum. So when you see status 0, that means it's this status. It's vacant. That corresponds to 0. And we're going to change it to occupied. It'll change the status to 1. So this is 0 and this is 1. And that's why we use status as vacant and then status as occupied. So we're not just saying like 0 or 1 throughout the code. It reads more like English. And then when you're reading information from the blockchain, it's going to give you zeros or ones or, numbers that correspond to however many statuses you have inside of here. So we can see the owner is, the owner is our smart contract. So let's change our address to the second address here. I guess I was already on the second address. Let's do a new address and let's try to book it. So let's try to book it and then, send in too little. So you can see the transactions reverted here. All right, that's because we didn't actually send in any cryptocurrency. So let me show you how to send in crypto. So right here, we have this thing called value. All right, you can see this amount is way. We can change this to ether. All right, we can send in ether with our transaction. So remember, we're calling this book function, but we want to send in cryptocurrency simultaneously. So we can put in, 2 ether here to actually book it. So we can click book and then green check mark. It worked. You see the current status is now 1. So it's occupied. All right. So it worked. Awesome. The hotel room is booked. It's occupied. Now let's redeploy the contract so we can, make sure that our other conditions work. We want to make sure that it's, that if we send in too little ether, it does not book the hotel room. So we'll just kill this. Oh, actually, that's fine. Let's click deploy again. And then now we have a new owner because we didn't change our account. That's okay. Let's see, current status is 0. Let's try to book and then send in, 1 Ether instead of 2. Click book. And we see that the transaction's reverted because we did not send in enough Ether to satisfy this. We only sent in 1 Ether. So now let's send in, 2 Ether. And click book again. And we keep clicking book. You can't book it twice. So it worked the first time, which is good, but you can't actually do it twice. Now I realize that I didn't change addresses here. I'm just sending it to myself. But if you really want to get ambitious, you can go through the whole process of redeploying, calling book. Well, actually, that's not what I meant to do. Let's go back to first account, redeploy. All right, and then, change accounts here, and then book, send in some 2 Ether. And it still works. Awesome. All right, so that's our hotel room smart contract. We demonstrated so many different concepts in this video, like modifiers, enums, how to send cryptocurrency. Congratulations, you've come a really long way. Let's jump into the next section. All right, so let's talk about some critical concepts that you need to understand in this lesson. So up until this point, we've basically just created a single smart contract that doesn't really talk to any other smart contracts. It has no relationship with them. It really just understands all the code inside of its own smart contract. So we're going to create some other smart contracts in this lesson, and we're going to have contracts interact with one another. One is through inheritance. We'll see what that means if you don't understand just yet. Basically, that's where you get one contract and you inherit properties from a parent contract. We're talking about factories, which is where you deploy other smart contracts within a smart contract, and then also how to talk to other smart contracts inside of smart contract functions to call other contracts on chain. So let's go ahead and jump in and get started. All right, so let's move this out of here, and then we'll just take it out. And so what we're going to do is create a contract that stores a state variable called a secret. So we'll say string secret. All right, what we're going to do is basically store this on chain and only allow a certain person to read the secret. So we'll set the secret like this. We'll say constructor, and we'll say string memory secret. All right, we'll pass it in whenever we deploy the contract, public. And inside of here, we'll say secret equals secret. Again, so this is the state variable secret that's stored in the blockchain, and this is the local variable that's passed in as an argument when the function is called. And we use an underscore here as just a convention so that we avoid naming conflicts. And so what we're going to do is also store an owner here. All right. So we could say address owner. Again, we talked about owners in the previous section. So owner equals message sender. All right, this is the person who deployed the contract to the blockchain, and we save that here. Okay. And so what we're going to do is basically say function get secret. All right. And we say it's public view. And then it returns string memory. And what we'll do is return the secret. All right. So now what we're doing is saving the secret on chain and having a function to get the secret. And we don't want anybody else to know what the secret is unless they're the owner of the contract. So, previously, in the last video, we talked about modifiers. So we could say modifier, only owner. All right. And then we could say basically require message sender equals owner. And then say must be owner. Let's actually make those double quotes, sorry. All right. So basically, this is a really common pattern inside Solidity where you have an owner and then you require that they are the only person who can call a function. So we can take this modifier and add it to the function here, public view only owner. All right. So now only the owner can get the secret from the contract. And so if you're any other account and try to call this function, it's going to basically give you an error. So that's our basic contract. Now I want to show you how to use inheritance in Solidity. So what is that? Well, basically inheritance is a way where you can put, behavior and logic and data inside of a different smart contract. And then you can basically link your contract to that other contract to absorb all that data, behavior, et cetera, functions, whatever you want to. I'm trying to define inheritance without using the word inheritance. Basically, you can have a parent smart contract and a child smart contract, and anything that you have in the parent contract, when you inherit to this child smart contract, you can basically get all that for free. So I'll show you what that looks like. We'll say contract ownable. All right, and this is really popular in Solidity, where basically you can have an address, you can have an ownable contract, and you put all the ownership behavior in this contract, like this. So you take the state variable of the owner, you put it here, and then you take the modifier of only owner, and you put it here. And then basically, to get all that for free, you just say is ownable. Right, that's how you inherit. You just have the contract in view in the same file, and then you say my contract is ownable. Okay, that's how you do inheritance. All right. So one more thing here, we need to do underscore. All right, now one more thing I want to show you is how to deal with constructors when you have multiple smart contracts that you're inheriting from with another constructor. So what we can do is copy this constructor and then, put it here inside of this contract. Okay. And of course, we don't want to have any arguments because we don't want to do the secret inside this constructor function. We just want to assign the owner as the sender. Okay. And then inside of here, we do not want to set the owner because we've already done that up here. But now we have two constructors. So how do you call this constructor inside of here? Well, one way to do it is like this. You can just call super. And so what that does is calls the constructor from the parent contract at a specific spot, which is right here. Okay, now you can put super here, or you could put it here. It doesn't matter. Sometimes the order does matter, and that's why you want to specify where you're calling it. But for now, we'll just do it like that. All right, so now we've talked about inheritance. And the last thing I want to cover is how to talk to other smart contracts inside of a smart contract, and also how to essentially deploy new smart contracts from inside of a single smart contract. So we're going to do that all in the same go. All right, so I'm going to minimize this so you can see a little bit better. What I'm going to do is create this new contract here called contract, let's see here, secret vault. Okay. And then inside of here, what we're going to do is basically move this logic for storing the secret inside this vault, right? It's like a safe where we keep the secret. And then my contract is going to, what it's going to do is going to create the secret vault inside the constructor. And then we're going to actually fetch the secret from the secret vault inside this function. Okay. So basically this is where all the secret logic will go. And this will be the contract that, interfaces with the secret vault. So we're going to move this constructor, okay, up here. And we'll say constructor string memory secret is public. And then we'll just store the secret. We don't need to call super because we're not inheriting with this smart contract. And then we will do get secret like this. Okay. And so we're not going to make it ownable because we don't have an owner here. All right. And now I'm going to show you how to create the secret vault whenever my contract is deployed. So this is what's called a factory. So a factory is a smart contract that creates other smart contracts. And really a factory creates like a multiple, like on demand. Uniswap is a really popular decentralized application that uses factories to deploy new liquidity pools. It's like anytime you want to create a new trading pair, you put new smart contracts on the blockchain. So we're just going to do one in this case. So it's not a true factory, but you'll get the idea of how it works. So I'll show you how to do that. We're going to deploy the secret vault here. Okay. So basically we're going to call secret vault. We're going to take it like this, take out this secret, and we'll say secret vault underscore secret vault equals new secret vault. And then we're going to pass in the secret. All right, so what is that? Well, how you create a new smart contract inside of a smart contract is you take the name of the smart contract, which is this secret vault, the same capitalization. You give it these parentheses, okay, which means, you're calling the constructor essentially, and you're passing in any arguments, which is the secret in this case, because the constructor takes a secret. And you also call new here. So you're saying create a new smart contract that's, got this code secret vault. It knows about the code here. And then give it the argument that it requires, which is this secret. And then basically you assign that to a variable here called secret vault, a local variable. And because Solidity is statically typed, we tell it the type, which is just this contract called secret vault. So it'd be just like if you said, uint my number, 1, 2, 3, 4, 5. You're just saying create a new, create a new variable of the secret vault, and then create the new secret vault here. Okay. And so now what we want to do is save the secret vault's address for reuse. So we'll create a state variable here, say address, secret vault. Okay, and we can save that. And then we say secret vault equals address secret vault. Okay, then we can call super here. So now we're creating a new secret vault. We're creating a new contract whenever this contract is deployed, and we're saving the address here so that we can reference it. Now let's actually get the secret from the secret vault. So inside of here, instead of returning the secret, because we don't have it anymore here, I'll show you how to call the other smart contract from inside of here. So we'll just say return secret vault. And then basically what that's going to do is reference the deployed smart contract, here. But we have to give it the address because it doesn't know where it is on chain. So we can just give it the secret vault address, just pass that in. And then we can call the function like this, say get secret. All right, so secret vault, and then pass in the secret vault address, and then get secret, and then that's going to return that to the function. And so that's how you call another smart contract from within inside of a smart contract. You give it the name of the smart contract, you give it the address, and then you call the function directly on it like that. Now, you could store this to a variable if you wanted to and do it multiple lines, but this is a nice one-liner that makes it nice and easy. All right, so let's go ahead and try to compile this and run it. So a couple quick things. We don't need these visibilities on the constructor anymore. It's just sometimes that Solidity changes between different versions. Used to be required, it's not anymore. So let's just take it off. Okay. All right. So then we're going to compile. And then no warnings. And let's go ahead and deploy. All right, so we'll start with the first account. We'll put in a secret. We'll say my secret. Okay, click deploy. And then we can say get secret. All right, so it'll actually return it. Now, if we change accounts here, let's see what happens. Okay, so it's not really working. So let's just demonstrate it so that it makes more sense. Let's say my secret. Okay, you can see it in the transaction log here, but let's just show you, like when I change here, say get secret. Yeah, it's been reverted, but now you don't even see it come back and remix because you have to be the owner to get the secret. Okay, but if you are the owner, you can do get secret, and it works. Awesome. So it's actually going through the entire thing. You know that it works because it's deploying the secret vault to the blockchain. It's ownable. And so we verified all the behavior in this lesson. All right. So that is an overview of how to work with inheritance and factories and how to call other smart contracts from within smart contracts. All right. So that's an overview of the Solidity programming language. So I really hope you liked this video and got a lot of value out of it. If you did, I spent a lot of time making this video. The only thing that I ask in return is that you smash that like button down below, subscribe to this channel, because that really helps YouTube share this video to more people so that more people can actually learn these in-demand skills of blockchain. And if you like this video and you want to take the next step, or hey, you want to go straight for the throat and become a real blockchain developer, I can show you how to do that over at dappuniversity.com/bootcamp and build a real world project step by step from start to finish. So make sure you sign up the link down below to get started today. That's all I've got. And until next time, thanks for watching Dapp University.